So where we left off yesterday, we had worked on an example of a problem, or started working on an example of a problem similar to what's on a quiz that I just posted for you to do today and Thursday. I want to work through the rest of that example here quick now. So we had a segment of a circle. I don't remember what dimensions we used yesterday, so I want to put new ones in there. I'm going to call this 48 feet here. And let's see, let's call this 16 feet here. We'll call this an 8-foot wall, 212 slope. We'll have this stick out 12 feet. And then change the way I draw this so it looks a little bit more like what we were doing yesterday. The 8-foot wall, I'll move back here. This will be 12 feet. And this is still a 212 slope. And let's make this 100 feet, and we'll make this here 16 feet. I want to find two things off of this. I want to find the volume of the whole building. This is what we had started looking at yesterday. And I want to find actually, let's make it three things. I want to find the roof area, and I want to find the wall area. So we'll find those three items. We did a similar example yesterday. So let's start out. There are actually two separate pieces we're going to work on here. I'm going to start out working on this piece here. A little bit bigger. So this is 48 feet across here. 12 feet here, 8 feet, 212 slope, and 16 feet. What I've done there is I've actually just cut out this section of the shed. And I've pulled it all out so that we can look at it separately. So that means that this is actually does have a depth to it. And that depth is 16 feet. So I just pulled out that 16-foot section that has that lean-to sticking off the side. And we're going to work on that right now. The first thing we have to do, of course, is find what the actual radius would be of this circle if it were a full circle. So we've got 48 feet across there. I'm just going to split that right away into 24 and 24. And we know this is 16. We'll find this dimension down through here, which is our dimension x. So we know that to find x, it's 24 times 24 equals 16 times x. So we solve that. We're going to divide both sides by the 16. So 24 times 24 divided by 16 is 36. So x is 36, which means the diameter of our circle here is 16 plus 36, which is 52 feet, giving us a radius of 26 feet. So going back over here, that tells us that what we need to add to this, we need to get this height down to 26 feet, so we need to get 10 more feet down on the bottom of that. Now remember, because this is a straight wall, this side comes straight down. This side, because it's part of the arc, is going to arc out. So it's going to be from center here out to there, it's going to go from 24 feet up to 26 feet. But here, from this center over, is still just going to be the 24 plus the 12 is going to be 36 feet. That distance doesn't change because this is a straight wall coming down here. I'm going to connect up here to that intersection of that roof to the circle. That is our radius of 26 feet. And I will connect to this corner here like this. I know I drew that a little curve, but I just wanted to make sure I don't go through this point here, because if I go through that point, it changes the math of it. I want to make it very clear that it doesn't, we don't know if it goes to that point or not, so we can't assume it. If we make that assumption, it changes a lot of the geometry of the problem. So make it clear that that's not true. So anyway, we're dealing with that triangle there right now. Right here in the light blue. The bottom we figured out to be 36 feet. The side over here is 10 feet plus the 8 feet that we had before. That's 18 feet. We will find the length here of the hypotenuse. Square root of 36 squared plus 18 squared. Here's 40.25, we'll call it. So it's 40.25 feet. We need to find the angles as well. This angle here with the inverse tangent of 18 over 36. Yes. Oops. Settings got to get changed to degrees here. The inverse tangent of 18 over 36 is 26.57 degrees. Which makes this up here 63.43 degrees. Because we got 90 degrees here, those have to add up to 180. The 26.57 is going to go here. Up top here, this corner. This is 90 degrees. This angle here is going to be our heel angle. It's the inverse tangent of our slope, so it's an inverse tangent of 2 over 12. The inverse tangent of 2 over 12 is 9.46 degrees. Which means this full angle here is 99.46 degrees. We subtract the 63.43 degrees. That means that this part of the angle up here is, what does that come out to be? 36.03 degrees. So now let's look at that triangle in green. We know this is 26 feet. This angle here was 36.03 degrees. And this side down here was 40.25 feet. Now we know this is an obtuse angle, but we can find it with our law of sines here now. 26 over 40, or not 40.25, over the sine of the opposite side of 36.03 degrees equals the 40.25 over the sine of that angle. I'll just call that angle alpha there for now. We're going to cross multiply and divide to get the sine of that angle. Sine of 36.03 times 40.25 divided by 26 gives us 0.906, 0.9106. So the angle, we got to do an inverse sine next of that 0.9106, which is going to give us second sine of that angle, 65.59. Now, of course, that's not our angle because this is an obtuse angle. We have to subtract that from 180. Here's 114.41 degrees is that actual angle. Which means this angle down here will be 29.56 degrees. I'm going to put that 29.56 in here because we're going to need that in just a little bit. While I'm at it with this triangle, because I know I'm going to do roof area, I'm going to find this side up here as well. So I still have the 26 over the sine of 36.03. Equals, I'll call that y for now, over the sine of 29.56. Now we're expecting this to be slightly smaller than 26 because that angle, 29, is smaller than 36. So we'll cross multiply and divide here. 26 times the sine of 29.56 divided by the sine of 36.03 gives us 21.82 feet. 21.82 feet. So we'll label that just so we have it for later. Next, we're going to find some areas. Well, first, let me fill in this angle here just to have it done with. That angle will be 180 because that's a straight line there. Minus the 26.57 and minus the 29.56 degrees. Making this 123.87 degrees, I believe. Now we'll find the areas. Now remember, this is the areas of the whole thing. We still have to come back and subtract out the pieces we don't need. Piece 1 will be this triangle right here that is 18 by 36. First, that's divided by 2, so it'll be 324 square feet. Piece 2 is this triangle. There's no right angles there, so I have two options. I can use Hero's formula, adding up the sides to get the perimeter, do the semi-perimeter, go through all that. Hero's formula is really kind of tedious if you don't have a better way of doing it. Remember, we've got that trig area formula for triangles, so we can do the two sides, the 26 times the 40.25 times the sine of the angle in between them. 26 times 40.25 times the sine of, what was that, 29.56, I believe. And of course, that is still over 2 because it is still triangle. So 26 times 40.25 times the sine of 29.56 and divide by 2. 258.14 square feet. And finally, we have this sector of a circle over here. There's a radius of 26 and the internal angle, central angle there of 123.87. That's pi 26 squared times 123.87 over 360. .14 times 26 squared. 123.87 divided by 360. It's 730.37 square feet. So I'm going to add all those up. $1,322.51 square feet. Now that is the area of that whole piece, including what we had added on to make this calculatable. Now we have to go back and subtract off those pieces. So I'll call this piece here piece 4. That's just going to be a rectangle that's 10 by 36. So 360 square feet. Over here, this one's piece 5, which is a 26 by 10 triangle. Sorry, that is not 26 by 10, that's 24 by 10. Sorry. Piece 5 is 10 feet by 24 feet. Divided by 2 because it's a triangle. It's 120 feet squared. And then I got this little sector of a circle that I have to subtract out here. I need this angle. Well, that angle will be the same as this one because these lines are both horizontal, meaning they're both parallel. So this counts as a transversal on parallel lines. So this angle up here can be found as the inverse tangent of, this is 10 over 24. What is that, 22.56, I'm going to guess? 22.62, sorry. 22.62 degrees. So this is also 22.62 degrees. So that area, that piece is pi times 26 squared times 22.62 degrees over 360. Give us 133.37 square feet. So that adds up to be 613.37 square feet of area. So we've got to subtract that over here. To get $709.14 square feet is the area of that end. Now at this point, I am going to find one of my answers. So 709.14 is the area of the whole end of this. In other words, it's the area of this plus this piece here. And there's going to be two of those. One on the other end here. You got this piece and then this little piece here. So I'm going to double that, and then to it I'm going to add this wall here, which is just an 8 by 16 wall. So 709.14 for the other end, and then 8 by 16, which is 128. So we're going to add those. Get 1,546.28 by wall area. 1546.28. So we've got our total wall area there. Not so bad, huh? Let's get back to that total volume. So for this piece here, that goes for 16 feet. So I'm going to take that area of 709.14 square feet times that distance of 16 feet. That's going to contribute to my volume of 11,346.24. Cubic feet. So that is a contribution to the volume right there. That's the volume of the portion with the lean-to. Well, now we have to go back and look at this piece here, where this is what, 48 and 16 still? The length of this, after we took out that 16-foot piece where the lean-to is, 100 minus 16, that's going to be 84 feet. Make sure I have my dimensions. That's going to be 84 feet here. So I have to find the area of this segment, and then I can go back and multiply by 84 to get the volume of that portion of the building. So I need to find this radius here. Of course, I'm going to do that by finding the whole circle. We already found that radius has to be, from the previous part, we found that radius has to be 26 feet. Found that right up here. So I'm going to cut this here. We know this is 24 feet. That'll help me get this angle here. That's going to be an inverse tangent, or not inverse tangent, inverse sine of the opposite side, the 24, over the hypotenuse of 26. Giving us 67.38 degrees. So this full angle here is double that, to 134.76 degrees. Now we're ready to go ahead and find the area of this segment here, this piece. We're going to find the area of the sector. Which will be that full piece, the pi times 26 squared times the 134.76 over 360. Giving us 794.57. Then we're going to subtract out the triangle. The area of that triangle, we're going to do side 26 times the next side, also 26, times the sine of the angle, so the sine of 134.76 degrees over 2. That's A times B times sine of C over 2. So 26 times 26 times the sine of 134.76 divided by 2 is 240, exactly. Square feet. And we subtract that to get 554.57 square feet is the area of this. So the volume of that portion is going to be that area times the 84 feet. Give us 46,583.88. Cubic feet. So literally just have to add those two pieces together here. Giving us 57,930.12. That's cubic feet. That is our volume of that whole thing. So we've got the wall area, we've got the roof area, or sorry, we got the wall area, we got the volume, we need the roof area. The roof area is also going to come in two parts. We're going to take this stripe here where the lean-to is, and we're going to find that area. Then we'll find the area of the rest of the roof, and we'll add the two pieces together. So on this piece here, I need this angle here. We had the 123.87, but remember, we said this portion was 26.62. We're going to subtract that off. (22.62 degrees). We subtract that, we get that this angle here is 101.25 degrees. So that's going to allow us to find this arc here from ground on the left side to where it hits that straight piece of roof on the right side there. So that length, that angle, 101.25, okay? So it's pi times our radius squared, the 26 still, times that angle of 101.25 degrees over 360 degrees. Oops, it's not going to be 26 squared, so it'll be 52. We're not looking at a sector area, we're looking at a arc length, so it's the circumference of the circle, which is pi times the diameter. So instead of pi times 26 squared with pi times radius squared is the area, we want the circumference. So it's pi times 52, pi times the diameter. So 3.14, come on, times 52 times that 101.25 divided by 360. Gives that arc length is 45.92. feet. And then we had the length of the straight roof here of 21.82. We're going to add that to it. Get 67.74 feet. That's the whole length of that roof from the ground up and then to the other end of the flat part. And that portion goes for a depth of 16 feet. We'll check that dimension. It is 16 feet. We multiply that by 16 feet. 7.74 times 16 gives us 1,083.84 square feet of roof area on that portion of the roof. Now we have to go back to the portion that does not have the lean-to. That's this portion here. We just need to find this length across here. We have that angle of 134.76. So that's going to be pi times our diameter, 52, because we're looking for the circumference. That gives us the full circumference of the circle, times that, what was it, 134.76 over 360. So 3.14 times 52, that's this whole circle, times the 134.76 divided by 360. Gives us 61.12. So that's the length of that whole roof. We have to multiply that times 84 feet is how far that roof extended. So 61.12 times 84 is 5134.08 square feet. And we're simply going to add those together here. Get 6,217.92 square feet of roof area. So we're looking at about 62 1/3 square there of shingles. If you're going to shingle it, 15 1/2 square of siding to do the walls. And if you're looking at 2 to 3 BTUs per cubic foot, you're looking at probably 150 BTU furnace, 130 to 150 BTU furnace to heat that area. So that's it. I mean, yeah, there's a lot there, but you can see we did it in less than 30 minutes today, about 30 minutes today. But once you get the form down in the steps, and I realized I flew through it today. I didn't pause for you to do any of the calculations yourself here, but I just wanted to go through it for you so that you'd seen all of the steps and so that this is not as scary as it looks. I mean, it is still a half-hour problem, but it's not the 45 minutes to an hour like we took on it yesterday when we slowed down and kind of dwelled on different steps. Now, the other thing I want to look at, we talked about it a little bit last week, but I want to make sure we discussed this again. It's called the slope correction factor. The slope correction factor deals with areas on a slope surface. So if I have a roof here, and let's say we have a 1612 slope, we'll get a steep one. If I have a circular chimney coming through that roof, and let's say this chimney is, well, let's make it easy on ourselves, a 2-foot diameter. The area of the circle that chimney forms, that cuts out, is pi times 1 squared. Diameter of 2 means it's a radius of 1, right? That's just going to be 3.14 square feet of area. But we know that as it cuts through the roof, so the top of that chimney would be 3.14 square feet of area. But we know that as it cuts through the roof, it cuts an elongated piece out of that. We want to know, how do we find the area of that piece, and how do we find the dimensions of that piece? And that's where that slope correction factor came into play. We have a 1612 slope, so this will be 16 inches. This will be 12 inches. Now I could use this to find the heel angle as well, but I don't need that. For right now, I want the length of this side. That length will be the square root of 12 squared plus 16 squared, which gives us 20 inches. I'll double check that. It is 20 inches. So the slope correction factor here is found by taking this hypotenuse, this length that we just found, divided by 12. 20 inches divided by 12 inches is 1.6667 is the ratio. Whatever something would be on a flat surface, it's going to take up an area equal to that flat surface times 1.667 on the slope. So we can find the area of that circle taking out of the slope. I'm going to multiply the 3.14 times that 1.667. Give us 5.233 square feet is what that would take out of the roof area. Now this slope correction factor can be used for other things as well. Let's say I'm looking at that roof, and to cut my hole, I know it's going to be elongated. I know that the width is still just 2 feet or 24 inches. I want to know how long I have to cut the hole in this direction. Well, it's the same thing. I'm going to take my 24 inches, which would be the width of that chimney on a flat surface. Is that slope correction factor? The 24 inches times 1.667 is 40 inches. So when I mark that out, I'll go 40 inches this direction and cut that hole out. So it gets stretched out down the surface. That slope correction factor is a very handy tool for us. Okay, so at this point, most of you have not finished yet. I think I only have like 2 people who have turned in quiz 425 from last week. I posted a new one out there, quiz 426. I encourage you to work together on these. I know you guys are in the school this afternoon. I am going to cut off the lecture here to give you all time to work. There is not a new homework today. There will be new homework coming on Thursday that'll be posted. But for today, I want you to finish up that worksheet from last week. We've worked on that for 4 classes now, so this will be the last class we spend on that. And to finish those quizzes. If you have any issues on them, let me know. Thursday we will answer questions on those quizzes before we move on into new material. So for right now, we will leave it at that for you. And I'm going to see if I can't get tech support to contact me for see if we can figure